Okay, welcome everyone. Today we're doing grade 10 paper 2. Grade 10 paper 2, it's an examination, provincial examination, November 2020, grade 10 paper 2. So last time we did paper 1, so today we're doing paper 2. So let's just get right into it. You can write it in 1 hour. It was not a long paper. So let's go straight into the questions. Okay, so I was working on this a bit. So let's try to do it. I was trying to figure what is happening here. In the diagram below, PQRS is a kite. So automatically you know the properties of a kite. With P, 3 and 5, S is -1 and -4. PQ and QR are the same. So this side and this side is the same. And they've told us here that PQ is 5 units. So automatically we know that this point. Okay, all right, perfect. Okay. Okay, the 90 degrees. Okay, cool. Okay, I'm sure we can find PR using theorem of Pythagoras if we ever asked to find this one. I think. Okay, let's do this one. So it's gonna be what 50 will be 2, something like that. Okay, no stress. Let's go on. And they tell us that RQ is perpendicular to the x-axis and its diagonal intersects there. Okay, so let's deal with this question right away. Show that the coordinates of R are 8 and 0. So they want us to find the coordinates. So the good thing about this, they've given us the coordinates. So for the fact that this R it's along the x-axis, automatically we have the value of y. I hope you can see that. Automatically we've got the value of y, which is 0, because anything along the x-axis, y is 0. Anything along the y-axis, x is 0. And then what we can use, already they told us that PS and SR are the same. So what am I going to do? I'm going to find the distance between PS, and then after I'm going to equate it to this one. So let's start with PS. So it's going to take a bit of time, but we need to make sure that we do everything accordingly. So let's try 1.1. Let's find the distance between PS. The distance formula is given by y2 minus x1, y2 minus y1. So our coordinates is what? This one and that one. Our coordinates, let me write them here. It's 3 and 5. And S is -1 and -4. Then we're going to do what? x1, y1, x2, y2. You just check, you just take the first one as your first coordinate, or the second one. It does not really matter at this point, because we're going to square the whole thing. So x2 it's -1, x1 it's -3 squared, plus x2 will be -4. This one will be, I hope it's a 5. Yes, it's a 5. Actually, this pen, can I use a different pen? It's a red pen, but it's fine. Here I have -4 squared, plus here is going to be a 9 squared, and then I'm going to have inside 16 plus 81. Okay, let's see it here. 16 plus 81. Okay, sorry about that. 81 plus 16 will be 97. Is it 97? 97. There's no square root of 97. Okay, 97. So that will be the distance of PS, I hope. Okay, then because of PS, can you see that PS and QRS RS are the same? I'm going to take this PS, equate it to what? To RS. They told us that PS is the same as RS. So I'm going to say, okay, the distance of RS, whatever that I'm going to find, is the same distance as PS. Right. So RS will be what? The coordinate of S is -1 and -4. The coordinate of R is X, do you agree, and 0, because basically we're looking for the X value. This one already we have. So what am I going to do? I'm going to write the normal way that you normally write it, x2, and then plus y2 minus y1. Okay, I'm going to take this one as x2, x1, y1, x2, y2. Do you all agree? Okay, okay, I hope you're following. x2 will be how much? X. x2 is x according to this. And then x1 is what? Plus 1 squared, plus y2 is 0 plus 4 square. So RS is the same as what? PS, and I have the value of PS is what? 97, square root of 97. So I'm just going to go ahead and put it right there so that we have only one unknown. First things first, I want to get rid of the square roots. I'm going to square both sides. When I square both sides, this one disappears. The square root and this cancels out because it's like a half times 2. It's going to be 1. And here we're going to lose the square root. And then we've got something like this. Right. Then what are we going to do here? We're going to move this one. Okay, can I move everything to one side? I can. X1 squared plus 16 equals to 97. Take this one that side. 97 equals to, it's going to give me 81, I believe. 81. 97 minus 16 will give me 81. Okay, I took it that side. Okay, it does not matter at this point. So there's a cool method of solving this. You can find the square root of each and then plus or minus everything. So let me do both the methods. Now here you can find the square. You can see this is a perfect square, this is a perfect square. So the square root of this one will be x plus 1, and the square root of this will be plus or minus 9. And then I'm gonna have x plus 1, which is minus 9, or x plus 1 equals to positive 9. I take the positive 1 and the negative 1, and then take this one that side. It's 9 minus 1, or 9 minus 1. X is 8, and then x here it's going to be 10. Can you see we're done? Or in this point, I'm going to work with it here. What we normally do here, we're going to expand this, something like that. X squared plus 2x plus 1. Take this one to the other side. That's going to be what? Minus 81 equals to 0. And then x squared plus 2x minus 80 equals to 0. So we have this now. Can I deal with it there? I hope you're with me now. I'm just showing you the normal way that we'll do it. So we're going to factorize what? We're going to factorize a trinomial. We're looking for the factors of 80. That will give us 2. So 80, 10, and 8. If I subtract these 2, will I get this one? Yes. 10 minus 8 will give me 2. So obviously I have that. X and 8 equals to 0. Now the signs are different because I have a minus, and then the bigger sign will take the sign of the middle term. So I'm going to put a plus, I'm going to put a minus. In this case, what do you do? Equate zero factor law. Equate each bracket to 0. X plus 10 equals to 0, or x minus 8 equals to 0. X equals to negative 10, or x equals to 8. Can you see? Whichever method you do, you're gonna find the same thing. Now listen carefully. You have two values of x. We need to choose. So how do we choose? We go back to the diagram. We look at which quadrant our coordinate or our point is. So the coordinate is at R. Can you see? It's in the first quadrant, and we know that in the first quadrant x is positive. So I'm going to take the positive and say r is 8, a positive 8 and 0. I hope you get it. Okay, write down the coordinates of A. Let's go on. Okay, so I'm on 1.2. Write down the coordinates of A. A would be the midpoint because of we know that they should bisect this diagonals. They should bisect this one here. So this part and this part should be the same. And then also, yeah, if we apply congruency, then these two sides are the same because of they told us that those two sides are the same. So 1.2 was just straightforward. You're just supposed to find the coordinates of A, which is the midpoint. The formula for midpoint is given as what? X1 plus X2 over 2. Yo, this pen, it's too short. Yeah. Okay. So the midpoint of A would be the midpoint of what? Of P and R. Now I have this one as 8. Now I can find the midpoint of these two things. So let me do it there. So what will be the answer? So let me write our coordinates here so that you can see them properly. R is 8 and 0. X1, Y1, X2, Y2. That's very important. Some they choose according to the letters. It does not matter at this point as long as your substitution is correct. So X1 will be 3 plus 8. 3 plus 8 over 2. 5 plus 0 over 2. It's what? 11. Is it 11? I believe it's 11. 5 plus 0 is 5 over 2. So that's your answer right there. So that one was not bad. 1.3, calculate the gradient. The gradient. Okay, 1.3. The gradient of what? Sorry, let's check the gradient of QS. Where's QS? SQ. SQ. Okay, perfect. That's a nice question. Yeah? So here I can apply collinear. They want QS. Can you see? But we know, according to collinear, if we've got points at the same line, the gradient here and the gradient there is the same as the gradient from there to there. I hope you get it. But in this point, this is a straight line graph. This is a straight line. So it gives me the coordinate of y for q, and this is a straight line also. It gives me the coordinate of what? Of y. So q is 8 and 5 if we're using these two things. But I'm going to use this. Maybe we can prove it. I'm going to use SA to find the gradient. As long as this is on the same line, the gradient from S to A will be the same gradient from A to Q. So we can prove that. But we're going to use our collinear here. So collinear says the gradient between SA is the same gradient as AQ is the same gradient as QS. That's what we're looking for. They want this gradient, but we can, if we have this gradient, then automatically we have this because of their collinear. They're in the same line, points that are on the same line. I hope you get it. So A, it's 11 over 2 and 5 over 2, and then what's the other one? S is minus 1 and minus 4. Okay, I hope you get it. I hope you can see what I'm doing there. So I'm going to choose x1, y1, x2, y2, and I'm going to find my gradient there. So I'm using SA. Okay, so y2 is what? Minus 4 minus 5 over 2 over minus 1 minus 11 over 2. Then you can work everything out there. Yeah. I think you need a calculator for that one. Okay, you can work it out, but just to save time, I'm just gonna press the whole thing on a calculator. 5/2. So I have minus 13/2 divided by minus 1 minus 11/2, which is also divided by 13/2. So minus 13/2 times 2/13. I'm just swapping this thing, cancel, and the answer is a +1. And it says a +1. You see, and it makes sense why it's a +1, because the graph is going up there. Can you see it's going straight? So let's check. So you're gonna say, therefore, since we said they are collinear, therefore the gradient of AS is the same gradient as QS. Therefore, the gradient of QS is also 1. But I want us to use those coordinates that we said. Let's check. I hope it works out. I haven't done it, but I'm pretty sure it will work out. Okay, let's try it. -1 and -4, and Q is 8 and 5. Okay? So x1, y1, x2, y2. I'm looking for the gradient of QS, y2 minus y1 over x2 minus x1. Okay, so y going to be 5 minus +4. Can you see? Because of the y is negative and it's coming with a negative. And then at the bottom, we've got 8 minus, so +1. Can you see? 9/9, which is 1. Wonderful. Can you see? So it works. Whichever one you use is going to work because they're on the same line. That's what you need to notice there. Okay, so they want the distance of PR. PR, I believe you can use theorem of Pythagoras also. I believe so. Because look, this is a straight line, and then here we're going to have a right angle. Can you see? We're having a right angle when we're dealing with that bigger triangle. So you can use theorem of Pythagoras, but let's just use what we normally used to do. So I'm on 1.4, determine the length of PR. So to be on the safe side, we're just gonna do PR. PR, like the normal way of doing it, x2 minus x1 squared plus y2 minus y1 squared. So this is just basic. We're still on the basics, I believe. Oh, what? Okay, so what are we doing here? Can I write the coordinates here so that you see? The coordinates of P is 3 and 5, and the coordinates of R is 8 and 0. You just choose. Even if you start with this one, x1, y1, x2, y2, it's gonna work out because we're squaring. So the answer will always be a positive inside because we cannot have a negative square root. So I'm gonna substitute now. 3 minus 8 squared plus 5 minus 0 squared. 3 minus 5 is minus 5 squared plus 5 squared. I'm gonna have what? 25 plus 25. This is gonna be a positive. I hope you can see it. 50. Do this 2 times 25. Therefore, square root of 2 times square root of 25. We end up with 5 root 2. That's the answer. That's the answer of the distance. I hope you are following. Are you following? Can you see clearly? Tell me if maybe I must zoom. Zoom. Calculate the area. Okay, this one we don't normally do it, but we can test it now. The area area is half over the diagonal 1 times diagonal 2. I don't know what method you use at school or in class, but that's what we normally do. So we're gonna take diagonal 1 is this one, QS, and then diagonal 2 will be PR. So what we're basically doing, what we're basically looking for here, we're gonna find the distance of QS, multiply it with the distance of what? Of voila, you get it, né? So here I'm basically looking 1 over 2 PR I have, that's the 1 times QS. So what I'm supposed to basically do is find the distance of QS and then work it out there. The distance of QS, you can use many ways to find it, but let's do this one. Okay, where am I now? I'm on QS. X2 minus x1 squared plus y2 minus y1 squared. QS, I showed you how we found the coordinates of QS. It was 8 and 5, and then S, it's minus 1 and minus 4. We're looking for distance. In the other time we were looking for gradient. Now we're on distance. So x1 y1, x2 y2. Okay, let's go on. Substitute in there. It's gonna be what? Minus 1 minus 8 squared plus minus 4 minus 5 squared. I'll work it out. Minus 9 squared is 81 plus 81. 81 plus 81, is it 162? Yeah? 162 inside. And then square root of 162. You see, if you're not sure, just use a calculator. See, don't be like a Hulk of maths. So you're just gonna multiply. So I'm gonna say area, it's 1 over 2 times what? Times 5 root 2 times 9 root 2. So this times this will give you how much? 45. This times this will give you 2. 2 times 45. It's 90, and then this will be 45. Let's see, 1 over 2 times 5. 45. Yeah, it's gonna be 90, and half of 90 is 45. You see, that's your answer right there. I hope you got it. Yes, let's go on. If I have a different pen. Okay, let's go to 1.6. 1.6, show that PR is perpendicular to QS. For two lines to be perpendicular, the gradient of PR multiplied by the gradient of SQ must give you minus 1. Do you all get it? So what are we going to do here? Do we have the gradient of PR? We don't have the gradient of PR, I think. We have the gradient of QS. We found it's 1. So we're going to find the gradient of this one. Multiply them together, we must get negative 1. So I'm assuming we might get negative 1 for PR. So that when we multiply them together, we get minus 1. So let's do it. Okay, I can do it here. PR. Can you see? Let me write the coordinates here. I hope you can see. No? The coordinates of P is 3 and 5. The coordinates of R is 8 and 1. So x1, y1, x2, y2. The gradient, remember, when we're talking about perpendicular and parallel things, we deal with gradient. PR, y2 minus y1 over x2 minus x1. Then we substitute. It's going to be 0 minus 5. This is y. And then over x2 is what? 8 minus 3. So I have minus 5. 8 minus 3 is 5. This will give me minus 1. Can you see? I get a negative 1. Therefore, I know the gradient of SQ is 1. So I'm going to say minus 1 times 1 is minus 1. Can you see? Therefore, gradient PR is perpendicular. That's the symbol for perpendicular. It's perpendicular to SQ. I hope you get it. We have proven because of their product must give us -1. Nice question. Okay, let's do the last part. Okay, so the last question, they're saying that show that PQRS is a isosceles triangle. How are we going to do that? What do you know about an isosceles triangle? Is that two sides are equal. So already they told us the two sides that are equal. Can you see? They told us that PQ is equal to what? To QR. Can you see? In terms of distance, they use the distance formula. So meaning the side that is not the same is what? It's PR. PR is not the same as these other two sides. So we're gonna prove it. You're gonna find the distance of PR, of which I think we did. We did find the distance of PR. Let me show you somewhere here. Where's PR? We found the distance of PR. Can you see? It's 5 and square root of 2. So this is 5 square root of 2. So we have proven two sides are the same. This one is not the same. Therefore, two sides are equal. Therefore, PQR is an isosceles because of the other side is not the same. If we calculated the distance here and we found 5 units also, then it wouldn't be what do you call it? What do you call it? An isosceles triangle. Can you see? So can you see how all these things are interlinked? So they're very linked. If they didn't give you here the coordinate of R, it was going to be a bit difficult to answer all these questions. So even if you got 1.1 wrong, at least you are able to go on and answer the questions, you see. And then by saying show that the coordinates of R is 8 and 0, they've given you the answer. You just have to work your way towards your answer. I mean, if you get something different to what you have there, you can just always go back and then redo the question up until you get it right. So I hope all of us, we have 21 marks in the bag. Okay, let's do trigonometry. Yeah, this one. Trigonometry says what? Okay. Let's deal with this one. I hope you saw the questions. So number 1, they say determine the value of sec 75 and round off your answer to 2 decimal places. Okay, not a problem. We know, I'm just going to revise a bit on this. Question number 2, we know that we've got what? Sine, theta, the normal trig functions that we know. There are 3. So I don't usually like making my life hard, and I don't want to make other people's life hard. I just memorize the 3, and then I can find the other 3. This is opposite adjacent over hypotenuse, and then opposite over adjacent. Yeah? Then we've got sec, cosec, and cot. How do you find? These are the reciprocals of our normal trig functions, this one. But what is the relationship between the two? The relationship between the two, we find it by counting the third letter of these ones. So how are you gonna know? You count the third letter and then it will tell you which reciprocal it is, or it should be, or it was, whatever you say. Let's count. 1, 2, 3. The third letter is C. Are you all clear? The third letter is C. So what does it mean? It means that this was the theta there. Sorry, The reciprocal of this is cos, 1 over cos theta. Can you see? The reciprocal of cosec, 1, 2, 3. So S is for what? For sine. So this is the reciprocal for sine. You just count the third letter. 1, 2, 3. T, the reciprocal of what? Of 10. Can you see? Nice. So on the test, you don't even have to know this. Just count the third letter. You just know what you know. You see, just like that. So therefore, sec 75 degrees is actually 1, 2, 3, 1 over cos 75. Can you see? Wonderful, wonderful. And then you press it on the calculator there. 1 over cos 75. You get that. Square root 6 plus square root 2. Rounded off to 2 decimal places is going to be 3,86 because of this 3. It's below 5. So the answer will be 3,86. There you go. I hope you got it there. Are we clear? And then simplify. Without the use of a calculator, simplify. So these are special angles. All right, special angles. Okay, all right. Okay, let's do it. Let's do it. So special angles, you need those two. There's two diagrams. Let's see if I had a different pen. This pen is not my favorite pen. We've got those two triangles. So sometimes they do, other teachers do, or other textbooks do 2 triangles there and there, but it does not matter. So this one is 1, 1, square root 2, 1, 2, 3, square root 3, 45 degrees. Angles inside must give you 180. And then this one is what? 60, 30. So normally, how do I explain this? I say, okay, this one is split between 30 and 60. Right? This one is split between 45. So it's quite easy. But I use this one as a point of reference. With this one, I say, okay, between 30 and 60. Because sometimes you're going to be confused. Okay, which one goes there? Which one comes here? Between 30, if it was measured in terms of kgs, kilos, let's say there is Tabo and John here, the heavier one will obviously have to go down and the lighter one will go up. See, so it helps to those who understand what I'm talking about. I mean, imagine if this one was carrying this one, you see. Yeah, blah blah blah. So put 30 on top, 60 at the bottom. Sharp. Case closed. Oh, why are we moving? Case closed. So we can answer this question. For 90, so 90, 180, what do you call it? 270 and 360. These are special angles. Eh? But for those ones, just go ahead and press the calculator. The ones that we need to deal with is these ones. So we're given sine 90 minus cos 60 over 1045. All right. So I'm going to write SOHCAHTOA here. SOHCAHTOA. That's our acronym for dealing with trigonometric ratios. So sine, I'm going to just go ahead and press it here. Sine 90 is 1. Yeah, don't worry about it. Minus, let's deal with this one. Cos 60. So I'm no longer on this triangle, I'm this triangle. I'm looking at cos 60. According to SOHCAHTOA, cos is adjacent over hypotenuse. If I'm here, if 60 is my point of reference, what is the adjacent side? This will be the opposite side. The adjacent side will be this one. 1 over hypotenuse, A over H, adjacent over hypotenuse when I'm here at the point of reference. So it will be a half over 1045. I'm no longer on this triangle, I'm on that triangle. According to SOHCAHTOA, OA, this as my point of reference will be opposite and will be adjacent. So 1 over 1. So 1 over 1. 1 minus a half is a half. Hey, look at this, man. 1 over half is a half, and over 1. So the answer is a half. Yeah, I think it was easy. So this one, let's try to check it. With this one, it was not so difficult because of they gave us even 2 marks for it. So, I mean, okay, what happened? I did not close the bracket there. Wonderful. Okay, it was 2 marks. So there was no square roots and all those things that we need to deal with. Okay, 2.3, let's go on. So at least we're revising while we are doing the thing, and then we are enjoying. Let's go on, mind our own business. So I'm here now. We're on the Cartesian plane. In the diagram below, A, X, and Y as given, they gave us this. It's a point in the 3rd quadrant. Very important, very important. This statement is very important. Sometimes they give you restrictions that maybe is between 180 and 270. So you need to know according to you 0, 90, 180, 270 and back to 360. If they give you according to restrictions, you need to know which quadrant we're in. So here they just go straight and say it is in the 3rd quadrant. What do we know about the 3rd quadrant? I'm going to start here. The value of X is positive. The value of Y is positive. So in the 1st quadrant, we've got a positive X and a positive Y. In this one, we still have Y is positive, but X is negative. So here we've got negative X and negative Y. This means that we're dealing with here, we have a negative what? X and a negative Y. Because of Y it's negative, X is also negative. This side we've got a positive X and a negative Y. I hope we're getting it. So what is this saying? Both the values of X and Y are negative. Negative. Are we all clear? And then you need to know the trig ratios according to Cartesian plane. I'm going to show you how they are. Okay, this is our Cartesian plane. How it got formulated. This is X, this is Y. Now let's say we've got a triangle there and we've got theta there. Obviously this is the X value, this is the Y value, and we know that if we've got a circle, from the center to a point of a circle, we deal with the radius. Are we clear? Are we clear on this one? This is a right angle triangle. So if I'm doing SOHCAHTOA, if I'm dealing with SOHCAHTOA, sine is going to be the opposite side over the hypotenuse side. So I'm going to say, okay, sine equals to, in this case, what is the opposite side? The opposite side is Y. The adjacent side is what? It's R. Do you get it? And then cos theta, what is the adjacent side? The adjacent side will be this one next to it. So it's X. Look at this man. Look at this man. X over R. The adjacent side over the hypotenuse. Can you see? And then opposite over adjacent. Tan theta will be, the opposite side will be Y over X. I know usually the normal way like will be X over Y, but it's not like that. It's Y over X. Y over X. Okay. Whatever. So the first thing that we have to do when we're given a question is to get it sine trig function to be alone and this side to have a fraction. All right. I was talking there. I was talking non-stop. Okay, we're given this. This means that we have to deal, and then we have to find the value of 30 tan theta without a calculator and calculate the size of A. Correct to decimal. Why am I saying correspond? You see, tiredness. Okay, I'm here now. Let's deal with this man here. We're given 5 sine theta plus 3 equals to 0. I said what? Excuse me. What's the first thing that we need to do? get the trig ratio to be alone, and on the right hand side we should have a fraction. So I'm going to take 3 to that side. 5 sine 5 minus 3. Divide both sides by 5. And then we've got what? Negative 3 over 5, and then we've got y over r. We've got y over r there. This fraction represents y over r. This means very important. Y is how much? Minus 3. R is how much? 5. This one, the ones that are corresponding or facing each other. Y is equals to that one, that one is equals to that one. So R is 5. Can you see? Therefore, x is what we're missing. We're missing x. And how are we going to find x? Using theorem of Pythagoras from this. Theorem of Pythagoras says r squared equals to x squared plus y squared. Then we start the substitution. So I have 5 squared. Can you see that y is negative there? Yeah. Equals to x is what we are looking for. Minus 3x squared. 25x squared plus 9. Take 9 to that side. 25 minus 9 is x squared. You get 16x squared. Do square root, do square root. X is how much? Plus or minus 4. You mustn't forget this. When we are here, the square root gives us a plus or a minus 4. Because of, why am I saying that? This, I can take x this side. Look. Yeah? I can take it this side. And then when we here, we have a difference of 2 squares. Can you see? We've got a difference of 2 squares. Then I'm going to, oh sorry, 4, ne? 4. So this is basically the difference of 2 squares. I'm going to have a positive answer and a negative answer. So if you're doing square root, you have to keep the negative and the positive. But now you have to choose. How do you choose now? The restriction comes into play. Very important. Because if the restriction, you don't understand the restriction, this will be wrong. Our diagram is in the third quadrant. What is the value of x in the third quadrant? Is it negative or positive? It is negative. Therefore, I'm going to take the negative answer. I'm going to say here, okay, I have the value of x is minus 4. Then once you have this information, can you see the steps I went to? Step 1, I wanted to make this to be in a form of the Cartesian plane, one of the trig ratios, and then look at the missing side and use theorem of Pythagoras to find the missing side. Use the restriction to choose the correct one, the positive or the negative one. Then, so A, B, C, then that's when you can answer your question. The question said they want 30, 10, theta. 30, 10, theta. How do you find 30, 10, theta? 10 theta according to Cartesian plane, it's y over x. So I'm going to say 30 open bracket y over x. I hope you're getting it. Yeah. 30 is equals to y over x. Okay. So 30, how much is y? Negative 3 over negative 4. You press this on a calculator, it will give you minus 90 over 4. How much is this? How much is this? Use a calculator. Obviously the answer is going to be positive. Yeah, what are you doing? What are you doing? Okay, I forgot a negative sign at the bottom. So the answer is positive 45 over 2. That's your answer right there. Can you see? Okay, let's try this one. What are they looking for? So here they want the size of B. They want to calculate the size of B. How much is B? So first thing first, we can see that B is an obtuse angle. Is that an obtuse? No, it's a reflex. Yeah, it's a reflex angle. reflex. Okay. Reflex angle. How do you know it's a reflex angle? Because it has went beyond 90, 180. It has went beyond 180. It's almost close to 270 now. So whatever we find as the value of theta, we're gonna add it to how much? To 180. I hope you're getting it. Yeah? So we've got our answer. We've got our diagram like this. If I include this, we've got something like this. We've got 5 there. We've got we've got a -3 there, and then we've got a -4 there, and we've got an angle there. So we can use opposite over adjacent. We can use opposite over hypotenuse, whichever one will work for us. Yeah. So which one are you using when you're looking for an angle? Whatever you want to use. Let me see. Let me use sine. Sine will be what? Okay, let me see. Because of this is negative, let's see if it will work out. Okay, -3/5. Okay, and plus 180. Okay, what am I doing? Okay, so let me take the one that has both negatives. Yeah. Let me take 10. 10 theta is what? Negative opposite over adjacent. So it's gonna be -3 over -4, which will give us this. Can you see? I'm trying to deal with positive values so that at least we've got an idea of what's happening. And then obviously I'm gonna say, what did I do there? Shift 10, 3/4. Yeah, will give us 36. 36 will be this angle right here. Will give us 36, and then I'm gonna add 180 to it. So 36,87 plus 180. Yeah, so something like 216,87 degrees will be our answer. But we should be able to find it. Shift and -3/5. Okay, perfect. You see, even if I used sign, I get the same answer. So here you should not include the negative sign when you're dealing with it. Just deal with this as positives, like distance. So you're gonna get the same thing. Cos will be 4/5. Shift cos 4/5. We have to get the same thing. See, so whichever trig ratio you use, you're gonna get 36/7 as this portion of this angle, but we want the full angle, so we're gonna add 180 because of angles on a straight line add up to 180 plus that portion. I hope we are together. Togetherness is the key to life. Okay, question 3. We're on question 5 there. And then we do this one, yeah? And then we are done. So this okay, there's a lot of right angle. The right angle, you can find this one. Right angle, you can find this. It's these people are playing their music here. This music is the one that is making us to be slow. And then with this one, we've got two sides, this and this. Can you see? Okay, we'll deal with it just now. Let's see this one. Consider the function. Consider this function as a trig function. So what are you gonna do in this trig function? You're gonna deal with it the way it's supposed to be dealt with. Okay, it's a trig functions. What do you need to know? Let's revise a bit. Y equals to sine x. So we need to know the mother graph of sine, which is It cuts at 1 and minus 1. Can you see? And 90, 180, 270, 360. Starts at 0, ends at 0. Something like this. The amplitude is 1. So now the amplitude is increased. It's now cutting at a different pen. It's cutting at minus 1, minus 2. Can you see? Something like that. It will be minus 2 then. So okay, I've already sketched it. They said I should draw it. We've already done it. It's only going to increase in amplitude. The height of the graph is going to go up because of here. This affects the height of the graph. Okay, write down the following. The period of f of x, we should know this, all of us, is 360, right? That's the period. And then if the equation of h, if h is a reflection of f in the x-axis. So can I do it right here? Reflection in the x-axis. That's the rule. X and y becomes what? Maps 2. Y becomes negative. So reflection in the x-axis, y becomes negative. Therefore, reflection in the y-axis. Reflection in the y-axis, x and y becomes what? Negative x and y. I hope you get it. Yeah. So what are they basically saying here? If they gave us, are you seeing what I'm writing here? If they gave us f of x, 2 sine x, we know that this is the same as y. I get it. So reflection in the x-axis, we want this one to be a negative. So divide both sides by negative, negative. So y will be negative 2 sine x, which is h of x is minus 2 sine x. So basically there are it's an inverse of that graph. So it's gonna start like this. It's gonna start going down first. You see, because this one is a negative graph 2. I hope we get it. Nah? I hope we are getting it. And then solve for x. Oh, let's solve for x now and see what will happen. What will happen? What will happen? Solve for x like you normally solve for x. Like come on, like the way you normally solve for x. So 4 tan x plus 1 equals to 3. Take 1 to the other side because it's a constant. 3 minus 1 is 2. I have 4 tan x there. Divide both sides by 4. Divide both sides by 4. Then 10x is what? 1 over 2. If you simplify this, 2 goes into both of them. And then we're going to do the arc or the shift. What? You're looking for x. One, this is like finding an angle. So we're going to say 10, it's 1 over 2. 1 over 2. X is how much? 26,57 degrees. Something like that. Yeah. And then cosec x over 3 equals to 2. So always when you want to get rid of people are tired of me saying this. Always when you want to get rid of a denominator, you must multiply both sides by the denominator. If you want to get rid of a fraction, you don't want to see a fraction, multiply both sides by what's at the bottom. Numerator and denominator is going to cancel out. You're left with cosec x equals to this. You multiply together. 2 times 3, it's 6. Are we all clear? Now here I need to do the inverse. The inverse here will be the reciprocal. 1, 2, 3 will be sine. So 1 over sine x equals to how much? 6. Okay. Then what am I going to do? I'm going to multiply both sides by sine. Multiply both sides by sine. Multiply both sides by sine. This sine and this sine goes away. We have got 1 over 6 sine x divide both sides by 6, and then sine x is 1 over 6. But here, you can just swap them, okay? Then, once it's like this, that's when you can say, that's when you can put it like that. Okay, 1 over 6. Yeah, I took time because I'm trying to explain and revise all the work. Otherwise, 9,59. Otherwise, we'll be done because of, it's almost close to an hour. While we're on one paper. Oh, man, one paper. Okay, let's deal with this one here. An architectural design for the front house is given below. The length of the house is 10 meters. The length of the house is 10 meters. So what are they saying? The length of the house is 10 meters. I think 10 meters has to be this part, the length. So this part is 10 meters. An exterior stairway leading to the roof. Okay, that's the stairway leading to the roof at an angle of elevation with the ground level, and the slanted part of the roof is 7 meters. This part is 7 meters in length. Okay, cool. Calculate the length of the vertical wall DE. Leave your answer in the simplest set form. Okay. So we have something. I can just take out this triangle outside. We've got something like this now. 10 here, 30 there. Then I can find this part. Do you all agree? Using soccer tool. So I have opposite. I have adjacent. So remember, you look at what is given and what you're looking for. I'm given the adjacent side when I'm using 30 as a point of reference, and I'm looking for the opposite side. So a trig ratio that has O and A will be TOA. So I'm going to say 10 theta is opposite over adjacent. All right, and then substitute. 10 angle is what? 30 equals to the opposite side. What's the opposite side? Is DE. It's what we're looking for. And then FE, it's 10. Multiply both sides by 10 because I see a fraction there. This and this cancel. I'm only left with DE. DE will be 10 times tan 30 degrees. Ah, man. Oh. Yeah, they said simplest side, so you leave it like that. They didn't say in a decimal form. Okay, calculate the angle F if the angle of elevation. Calculate the angle of elevation at the top of the roof from the ceiling CBD. Correct your thing to 2 decimals. Okay, cool. So listen to this part. So this roof, this length here is 10. And then these two triangles are congruent. You can see this side and this side are the same. They're shading at this side, this an angle this side, meaning this part and this part will also be equal. It's gonna AC, it's cutting into 2 equal parts. So meaning BC is 5. I hope we all agree on this one. It's 5. So that when I add these 2 together, I get 10. Are we clear on that one? So as if I'm using this as a point of reference, I'm given the adjacent side, this side, and the hypotenuse side. So the adjacent side and the hypotenuse side. How am I going to find that one? Which one has A and H? Is cos. Why am I saying cos? So car2. It's car. So cos theta will be, what is the adjacent side? 5 over 7. So theta will be 5 over 7. Shift cos 5 over 7. Okay, theta will be 44,42 degrees. Did they say? Yeah, they said 2 decimal places. I hope you can see the work. What if I'm working in vain? Okay, cool. And then calculate the length of AC. Where's AC? Okay, AC is this side. Can you see? Is this part of the roof? So yes, I'm gonna have to draw it here. Here. Oh man. How many minutes left? You see, time up. But we're doing the last question. Time up. AC. Okay, draw this short, small triangle. This side is given as 7. This side is given as 5. Now we've got this angle as 44,42. We can use this angle. We're looking for AC. Or we can use theorem of Pythagoras. Come on, I'm sure you can all see it. So we're gonna see what 7 squared equals to 5 squared plus AC squared. Right, take this one. 49 minus 25 will be AC squared. 49 minus 25, it's 24. AC squared. Square root of 24 AC, it's 2 root 6, which is what? Which is okay, it's going to be 5 units, yeah? Because it's 4,898. So here is going to be okay, or 4,90. Yeah, it's fine. You can, the answer is this one, or you can just round it off to the nearest decimal. Thank you, everybody. 1 hour of doing maths. We did the whole paper under 1 hour. Thank you. Please like the video, share, comment, send the link to your friends, help them prepare for the exams, and then I'll do another paper just now, maybe another question on paper 1. I can send through questions.